Hello guys, so today I've just discovered how to create a Bezier curve, sort of reverse engineered it, and I made this quadratic one. It's kind of complicated, like really complicated. So I think instead of just, like remaking that, I might just make like a simpler one for today's video. So yeah, we're going to start by making some points. This one's going to be pretty simple. And we're just going to have 3 points, which makes it a quadratic, I believe. Like quadratic Bezier curve. We'll move the points around so it's not just like that. Okay, so cool, we got like a little triangle. Alright, so now it's a pretty simple matter, I do believe. Let me just see if I can remember it. I think it's 1 minus kt. You don't actually have to have the k in there, the k just allows you to animate it, right? If you have the t in there, it'll make the curve just fine, but the k, 0 to 1, allows you to animate it. So that's really cool. Alright, so yeah, you're going to want to start off with that. We'll have C0 there. And what would our highest power be? Squared. Let's just, we'll work around it, we'll do a bit of experimentation and whatnot. And just see where we go. So that one will be like that, T, C1, and then finally we just have T squared, C2, and that should be it. And so here's our curve, we can animate it, and that's it being drawn. Okay, the fact that it moves like that suggests that I fucked it up. Oh yeah, right, you gotta have K's and all the T's, it's very important. The actual version that someone else made that I saw, I think was a bit inefficient, to be honest. I don't mean to brag, but mine's like not much cleaner because I take advantage of like parametrics like with points rather than, because they did like the whole thing as like an expression of like that sort of thing, defining an x thing and a y thing, but I just shoved it all into like points, I guess. I don't really know how to explain it because it's a very unorganized or unprofessional learning I've done. I've just done it on the interwebs. I haven't like learnt it in schools, so I don't know the actual terminology and shit. Yeah, so my learning's full of holes and shit and not very reliable. Anyway, but how do we make the cool little bits that sort of show you where the curve comes from and how you would draw it in real life, right? Like these sort of dashed lines here. Well, it's quite simple, really. All we want to do is start with a polygon. So, C0, C1, and C2. We'll get rid of the fill. And, there's our little triangle polygon, right? Alright, so now what we want to do... Although, actually, to be honest... I would do that for bigger ones, but it's probably just easier to just go like, actually, C1 minus C2 times by T, shit, wrong C, C0 times by T plus C0. I think I actually learned how to do that in complex numbers for some reason, just as a random side note. Don't know why I learned like this vector skill, I guess. So yeah. Anyway, so just like that, we have our curves. And they're looking fresh. I'm gonna make this one black. Okay, cool. So what do we do now? Well, we just want to basically grab these two things right here, copy them, and we'll move them down, set them next to each other. Replace the T's with K's. If you're not animating it, you wouldn't bother making this thing. And as you can see, we now have these points, right? So what do we do with these points? We connect them. So we can just say this is equal to... C00 is equal to that. And then we'll say C01 is equal to that. Alright. And now what we can do is a very simple C00 minus C01. It doesn't really matter which way around you do it. Just remember that the one you're subtracting needs to be the one that's like the translation of the curve thing. Anyway, yeah, no. There you are. You got the dashed line. And now we have like a nice animated little thing. As you can see, it just sort of like tangentially is drawn by this red curve bit, if that makes sense. See, it's like a tangent to the red line. And the more points you add in, obviously, the more layers of the lines. As you can see, the red ones are layer 1. I'm going to call the purple ones on the very outside layer 0. Layer 2 would be the blue one, and then finally 3 is the red one. Green one. Fuck. So important notes with making this, because, like, you know, if you want to make a different size, there are different rules there. You're going to need to know Pascal's triangle. This probably isn't the best thing to show it on, but it looks something along the lines of this. Yeah, just like that. 1, 4, 6, 4, 1. Yeah, and, you know, you just go down, down, down. Yeah, if you don't know your Pascal triangle, you can look it up. So, yeah. Can I organize this? Let's have a look. There we are. Look at that. It's a nice little pyramid. And yeah, so right with this one, we've done a quadratic. So we go down to this one. Cubic would be this one. And a quartic would be this one. And you can go down further if you want to. So I might go like 1, 5, 10. I should probably have commas at this point. 1, 5, 10, 10, 5, 1. And yeah, so on and so forth. But yeah, that's about it. Enjoy curves. Bezier curves are the best curves. They're just kind of like complex, I guess. I'll move around this one so you can see, like, with more points you can do some more interesting shit. So as you can see, I've made a really interesting curve here. And yeah. Of course, I probably could have defined a lot of these things and like made them a bit shorter, but I didn't. So yeah. But yeah, Bezier curves, they're pretty fun. So yeah, that's about it. See ya.